Hi, I'm Mansha. This is my submission. Uh, I've made PromptClash AI. This is the real-time AI creative battle room built as a full-stack application. So let me walk through it. So I am here logging in. So this is the identity lobby. Here we start the identity screen. User, as we have seen, the user enters the name and email ID here. Now I intentionally chose a lightweight identity system because the assignment explicitly allows mock authentication, and I wanted to focus more on engineering effort on the battle room experience rather than on complexity. So once authenticated, user enter the dashboards, and from here we can create a room and we can add the prompt to here. So I'm creating a room and now I'll add the prompt here. So this is the participant window. The private window was not visible, so I've opened in this only. So your participant joins the room through the same code. So the round one has begun. So once started, the host can start the round, score, and eliminate the participant. And the participant can join the room and submit the prompt. Here appears the prompt where I've already submitted. So after submitting, the prompt appears here, and this is the life cycle of it. After that, it gives the output. So talking about the host thing. So this is the host window, the roster one. Here we can see the scores, the one who has eliminated or not. The scores appear here, scoreboard. Here we can see who all are active and eliminated. Coming back to the participant window, after submitting the prompt, it appears here the backend creates asynchronous generation of job. This is important because it prevents the long running AI task from blocking active user. The async job lifecycle, as I told, the queued, running, completed. This is the lifecycle. These state are explicit and visible to users too. So the room updates this in a real-time WebSocket events. So both host and the participant can see the same progression without refreshing it. The system also supports the failure handling, ensuring that the failed generation do not break the room experience. As the assignment has required asynchronous job execution and visible state transition, which is why the generation I have modeled as a job rather than a direct request response action. So this is the generated output. It's completely AI generated campaign here appears automatically inside the submission feed. This is the entire submission feed. So scoring and judging the host, as I showed here, we can see. Also the eliminated one we can see, which is eliminated by the host. Let me do it again. Suppose here we are adding the score, and suppose we are eliminating this one. So if we refresh the page, while refreshing it recurs and it is persistent. So this is also, so just now I refreshed, we can see we have eliminated two players, and also we have scored this one. So after refreshing, we can notice that the entire room still exists. The challenge remains, the round remains, participant remains, submission remains, the generated output remains, elimination state remains. So this entire frontend restores the state from backend data, ensuring refreshes never destroy the battle flow. So for this, the technical architecture for frontend, I've used Next.js, TypeScript, Tailwind, CSS, Zustand, Freeware Motion, and for the backend, I've used FastAPI, SQLite, WebSockets, async background job processing. So, so the real-time synchronization is handled through WebSockets. Database is handled through state persistent, uh, and and for this assignment also, I have intentionally chose the SQLite for its simplicity and fast local setup. Async background job instead of blocking requests, so to form a one complete playable round instead of multiple unfinished features. So for this, my goal was maximize correctness, clarity, and reviewer experience rather than infrastructure complexity. So if I have to take it to further uh, for production levels, suppose, so I will use Postgres, SQL, Redis back workers, distributed WebSockets, automated integration test, AI-assisted judging, deployment infrastructure, and recurrently recovery to add the multiplayer features too. So rather than optimizing for the feature count, I've optimized more for the correctness, explicit state management, real-time behavior, and complete playable product loop. So thank you for watching.